Hi, everybody. Welcome to Math Parent Night. I'm glad that you could be here to join us virtually, and we hope that you find tonight to be very helpful and informational to you and your student. So hopefully you guys are watching this together, and this will help you to better understand how we want you to solve complex word problems like those that are on a lot of the tests that we take. So let me go on to the next slide. We're going to be adding and subtracting fractions with unlike denominators tonight. So that means that the denominator, or the number on the bottom of the fraction, which tells us how many possible pieces could be in our whole, will be different. So those questions are a little bit trickier, and we have to draw models to see how we can make the denominators the same. We're going to be using our UPDC framework. So what that means is that we want to visualize what the problem is asking us, understand it, and in order to do that, we write a fill-in-the-blank statement. So we figure out what the question is asking, we figure out what our answer is going to be, and we use that as a blank. So we don't have to solve yet, but we know what our end goal is. Then we make a plan, and sometimes that's just saying, okay, are we adding, subtracting, multiplying, dividing, or how are we going to solve the problem? Are we going to work backwards, look for a pattern? What do we want to do? Then we solve the problem. This time we'll be using models, and we check. We ask ourselves if our solution makes sense, or we can even use a different method to check. Let's try a question together. Mrs. Kaiser was making hot chocolate. For the first pot, she used 1 1/8 cups of cocoa, and for the second pot, she used 2 3/4 cups of cocoa. How much cocoa did Mrs. Kaiser use for both pots of hot chocolate? So our first step is to understand the problem. We need to ask ourselves, what is this question asking us? Well, I know that I want to find out how much total cocoa Miss Kaiser used for both pots of hot chocolate. So I wrote a fill-in-the-blank statement to help me here. So Mrs. Kaiser used blank cocoa for both pots. I should have said blank cups of cocoa for both pots here because I know that I'm looking for cups because that's what I'm adding is cups. So we're going to figure out how much total cocoa Mrs. Kaiser used for both pots, and our answer is going to go right here in this blank. So let's see what our plan is. Our plan should be to do 1 1/8 plus 2 3/4 because that's from the first pot and the second pot. So I need to add them together to see what my total is. So let's do that. I went ahead and drew my wholes. Okay, so I know that I have 1 whole cup of cocoa plus 2 whole cups of cocoa from the second pot. But now I also need to add my 1/8 and my 3/4. So let's do that. So I'm going to draw 2 fraction bars, one for the 1/8 to draw and one for the 3/4. I can't put them in one because they're different size pieces. Remember, we're doing unlike denominators. So let's split the first one up into 8 pieces. 8 pieces. All right, there's my 8 pieces. And then I need to split my second bar up into 4 pieces. So I have 8ths here in the top fraction bar, and then I have 4ths here in the bottom fraction bar. But I don't have all of those pieces, right? I only have 1/8. There I colored in 1/8. But then I also have 3/4 that I'm adding to it. So I went ahead and colored in 3/4. Well, we've sort of run into a problem. We've added, right? We know that we have 3 whole cups, and then we have 1/8 and 3/4 cups, but I can't do 3 and 1/8 plus 3/4. I need these denominators to be the same. So look, how can I make them the same? I can't really make my 8ths into 4ths. I can't make a piece bigger than it already is, but I can cut my 4ths down into 8 size pieces. Let's see what that looks like. Okay, so here we can see that 1/8 is also down here, but it takes 2/8 to make a fourth. So it would take 2 of these pieces to make a 4th-size piece. So we know that 2/8 is equal to 1/4. So I can split my fourths up into 8s. Let's see what that looks like. Okay. Oh, so now I have equal size pieces for both of my fraction bars. I have 1/8, and then I have 3/4 here, or 1, 2, 3, 4, 5, 6/8. So I have added together, right? The stuff in yellow and purple is what I have, and I ignore the blue stuff because I was adding. So I have 3 wholes plus 1, 2, 3, 4, 5, 6, 7 eighths. 7 eighths. So I used models to find like denominators in the eighths. So I have 3 and 7/8. And the next step is to check. So we can check using our calculator or another method. If you knew at the beginning that fourths and eighths kind of go together, if you knew that 6/8 was equal to 3/4, then you could see that I would have 3 wholes and 7/8. So our answer definitely makes sense. You could also just type this into the calculator to check it. So now I want to point out something super important to you when you are taking any of these standardized tests where they want you to put in your own answer. So this is what those test sheets look like. You can only use digits 0 through 9. You can use a slash in your answer, which we're going to need. But notice here it says that answers that are mixed numbers must be entered as an improper fraction or decimal. So our answer was 3 and 7/8. Let me go back. Sorry. 3 and 7/8. But it must be entered as a decimal or as a mixed number. So one way to fix that is just to put 7/8 into your calculator, and it gives you the decimal 875 thousandths, or 0.875. So you could enter 3 decimal 0.875, one in each box, 3.875, or you could make your 3 and 7/8 into a mixed number. So all you do is find the total number of eighths in that mixed number. So you can multiply 3 times 8, since we have 3 wholes and 8 pieces in each hole. So that equals 24, but then we need to add our 7/8 to it. So 24 plus 7 is 31. Our mixed number would be 31/8.